see. Should be live. I think I see some people already here. If you can hear me, say hello in the chat. And if you want to share maybe where you're watching from, that's always really fun. And then also maybe why you're interested in learning about machine learning, or if you have previous experience. So it's kind of fun to see what, where the audience is coming from. And we'll get started here in a minute, going through some slides, and then we'll go into the hands-on code portion. But I want to give a minute or two for everyone to join in. So as you're joining in, definitely say hello in the chat, in the YouTube live chat. I'll type in there right now as well. Someone said, hello, San Jose, new to Python. Awesome, welcome. Very exciting. I was actually just in San Jose last week. I was at NVIDIA GDC. That was pretty fun. I've gone down there a couple times in the past, but it had been a while. So if you have any recommendations for me next time I'm down there, let me know. And someone said they're watching from Kirkland, Washington. And yeah, I'm streaming from Seattle. Someone else said they're in Seattle, checking into the nuts and bolts of ML, new to Python also. Awesome, welcome, yeah. And if you're new to Python, this is great. Hopefully this will be a good starting place for an intro to machine learning with Python. I might do an intro to Python kind of workshop again if people are interested. I used to do those in the past as well. I'll be walking through all the Python code, and this is meant to be a good intro level. So even if you're not super familiar with Python, even if a little bit of it is over your head, that's totally okay. But I'll be walking through the code, and you can always come back and kind of pick apart the code a little bit more later. Someone said hello from Victoria, British Columbia. Awesome. I'm in Seattle, so like I said, I'm not too far from there, but I haven't gone to Victoria yet, but I want to go over soon. I think you can just take a ferry from here, and yeah, it seems pretty cool. I kind of want to go over there during like December or something. People said it's a cool place to go. And again, we'll get started here shortly. I think I'll just wait like one more minute before we get into moving along. And again, for people just joining in, say hello in the chat. Someone else from Canada watching from Calgary. Very cool. All right, I'm going to make sure my screen can share, and I'm assuming people can hear me because they're answering questions in the chat, so that's good. And I'll share my screen. And I'll recap this in a second too, but we're going to start with some slides real quick, kind of just talking high level about some machine learning concepts, and then we're going to go in and do like a hands-on code portion. So hopefully no matter where you are in your journey, you'll kind of learn things at a high level, and then we'll actually hop into some code and run things there. And people can see my screen, right? Are you ready? Are you ready to go? We're going to train a machine learning model too. So if you've never done that before, you can update your LinkedIn that machine learning. And I think also streaming to YouTube, I think there's like a few seconds delay between me asking and you hearing. So sometimes after I ask a question, it might seem like a really long pause because it might take a little bit to get to people before they chat. All right, so this is an intro to machine learning with Python and scikit-learn. Quick agenda about this workshop. So hopefully this is a super friendly introduction to machine learning with Python. It's kind of designed, where there's no previous experience expected, but definitely knowing some programming will be helpful. And we're going to be using Python. So if you do know a little bit of Python, like people said they're new to Python, I'm not sure if you've kind of looked at some of the resources and you've written, some lines of it, that'll be very helpful. But I will be walking through the code as we go. And also, it's a live workshop. Please ask questions in the chat. So if you want me to go over something, I'll try to do that. Sometimes if there's a lot of chatter, I might not see it. So ask it again if I don't get to it. And if it's something that derails the workshop a lot, maybe we'll come back to it at the end. So again, we're going to cover some high-level concepts here in the slides, and then we're going to train a machine learning model with Python using some code. And also just keep in mind, you can't learn everything in an hour, especially in the field of machine learning or really any programming field. But I feel like especially right now, machine learning. So parts of this might be, feel fast paced or challenging depending on where you're coming from. That's totally okay. Just keep learning after this workshop. And then again, ask questions in the YouTube chat where people are already talking. Ask them in there as we go. A quick introduction. I'm Sage Elliott. I do stuff with AI, machine learning, and ML ops, which is kind of building the infrastructure around machine learning applications. I'm at a company called Union AI. We build tools for workflow orchestration. So it's kind of a core piece for if you're shipping ML models at scale. Like every big company has some form of an orchestration platform to kind of run and train their models and scale them up on, Kubernetes, like GPU clusters, etc. We build a platform for that. And a lot of people do know us from our open source work, which you can check out on GitHub at Flight. It's a really popular workflow orchestration tool. And then also Pandera, which is a popular Pandas data frame kind of quality checking tool, which is cool. And you can connect with me on LinkedIn if you want to stay connected there. And I post, all the other workshops and talks and stuff that I do around machine learning. If you like them, you'll probably see them pop up over there. For the last about a decade, it's over now, I'm getting old. I've worked in software and or hardware with startups and agencies around Seattle, and then also some in Central Florida. And in general, I love making things with technology, and I want to do more hobby robotics stuff again this year. It's fun combining like software with hardware. I think is really cool. About you. So I know some people already put in the chat, but if you just joined in, say where you're watching from. Maybe if you said that before and you want to elaborate a little bit more, why are you interested in machine learning? Are you looking for like a career change? Do you have a specific project in mind? Are you working on something right now at work? Let me know in the chat. It's always really fun for me, but also for everyone else, I think, watching this live to kind of see a little bit more about the audience. So a lot of people said, they're new to Python. That's awesome. You're hopefully going to be in the right place. This should be a friendly introduction workshop, but maybe you already have experience with Python or other programming languages, but you've never done machine learning. Let me know in the chat. And then also, all these links, by the way, or most of these should also be in the YouTube description. So if you're watching a recording of this, which again is going to be at the same link that you're watching right now, so if you do have to leave and come back, you can find the recording at the same link. But all these links should be in the description below as well. And I'm going to share a link to a Slack channel. So I won't be looking at this during the workshop. This is going to be a place like if you want to stay connected later. I'm in there a lot and doing other stuff around like MLOps and actually also running a AI book club that meets every week. I actually see some people from the AI book club in this workshop, so that's really cool. And next week we're starting a new book actually called Grokking Deep Learning. So if you're kind of newer to deep learning or machine learning, it's actually probably a pretty good book to get started with. So I'd recommend maybe join the Slack channel, check out the AI book club channel in that group. Also, there's the introduction channel, so you can say hello in there, and it's a little bit more of a permanent introduction, and we can stay connected a little bit later. But it's not required for this workshop. I won't be looking at it during this, so keep asking questions in the chat here, but this is for later if you want to stay connected, and also maybe join in the AI book club thing we're doing. It's been pretty fun, I think, so far. Someone said they're watching from Melbourne, Australia. Another Washington. Someone said they're currently taking a Python class. Awesome. All right, so a quick note on setup for this. So you really just need a modern web browser. I'm guessing whatever you're streaming on is fine. I've really only tested everything on Google Chrome, but a lot of stuff's even built on top of Google Chrome, so everything should probably work here. And then you'll want a Google account if you're going to kind of run the code and save your own project. I'm assuming most people also have a Google account. We're going to be using an online editor and kind of whole environment for Python and machine learning called Google Colab. And we'll get more on that later. And again, the links to these are on the description as well. But everything's also going to be at this GitHub link. So if you want to go ahead and start poking around at code, or you want the links to these slides, etc., everything lives in that GitHub repo. And then I'll walk through how to actually set up and make your own copy and stuff like that when we get to that point with our code. Someone said they've done some coding with Python and C, and they're fascinated by AI, and thought they wanted to know more how to use it in projects. Very cool. Yeah, and there's so much going on right now. It's a great time to be jumping in. And then we're going to be using Python, like we've talked about. We're going to use a very popular machine learning library called scikit-learn, and then also a little bit of pandas, and we'll see again what this is when we look at it in action. I think also someone asked a question, do we need to know pandas or NumPy? Not really for this workshop. We're going to use a little bit of pandas and I think one line of NumPy, but again, you don't need to be familiar with it to follow along here. I'll kind of walk through what's going on. And someone said they're currently watching another person from Washington, and they're thinking about either transition from web dev to ML or learn how to integrate ML into web dev projects. Awesome. Yeah, there's a lot of cool, interesting, like, I think ML to web stuff that I've seen a while ago. I haven't kept up with it, but like you can run on WebGL, you can run deep learning and stuff like that in browsers, which I think is really cool. So what is machine learning? So again, at a really high level, and if people want to put in, you know, like what they've seen with machine learning or how they would define it in the chat, you're more than welcome to as well. But to put it really simply, machine learning could be thought of I'm stumbling over my words. Sorry, let me start that again. To put it simply, machine learning can be thought of a statistical model based on a data set to solve a problem. So usually, if you have done some programming before, which it sounds like some people have, you've maybe explicitly programmed, you know, control statements saying like, if data is under this amount of value or above this thing, do this. And then you might have a whole stack of those. And maybe that's how you would like classify if that piece of data would belong to a certain class or something like that. But that gets really, really hard when you have much more complex patterns. So I have a little bit of a computer vision background too. And I think, you know, as humans, we've seen a lot of images in our life, most of us, or I mean, just looking through our eyes. So we kind of understand computer vision. But if we were to manually write a classification algorithm in Python or any other coding language to classify if a picture is a cat or a dog, like how would we do that? It would be really hard. We'd have to probably go through like pixel by pixel and maybe have sections that we think would be a good indicator of if it's a cat or not. Like maybe it's the ears or something like that if they're more triangular. It would be really hard to do. But what we can do with machine learning is we have a machine learning algorithm that we've selected that we think is going to be the right one for the task. And we'll talk more about that later. But in this case, this example would be a computer vision one. And then we would pass in images of cats and dogs, and then we would have a label tied to that image, in this case, and say, you know, here's a representation of a dog and a cat. Now learn the differences. And we'd pass that data in usually to this function a whole bunch of different times, and it would learn what makes up, you know, a cat versus a dog. And then you'd pass in a new piece of data that it's never seen before, and you would get a prediction back. And if you trained your model correctly, hopefully it would give you the right prediction of, yes, this is a cat, or this is a dog. In like that would be really, really hard to do without a machine learning algorithm. And so really it's just machine learning is really good at finding patterns. It's kind of really all it's doing behind the scenes, even with like generative AI stuff. If you pick it apart, it's all kind of around pattern recognition, or in case of the Gen AI part, like pattern recreation. So who uses machine learning? At this point, kind of almost everyone. It's hard to think of an industry that isn't kind of adopting ML in some way. And again, if you have ones right now that you're thinking about, or that maybe you want to learn machine learning so you can go work in this problem in that industry, put it in the chat. I'm going to list out some examples you've probably seen, and then some other industries here in a second. But I always love hearing about like what are other people thinking about. So definitely put that in the chat. So more and more companies, right, at this point are making decisions with machine learning and data. Here's just a few examples you've probably already experienced, that you experience all the time. You have, you know, movie and product recommendations. You turn on Netflix or any of the big streaming sites, and they have a massive library. And it's really hard for you to kind of just browse through all of it and select what you want to watch. So it kind of relies on having a good recommendation system to push content to you that they think you're going to want to watch. Digital assistants. Probably used something like Alexa or Siri before. You've probably seen delivery robots, or maybe you haven't seen them in person, but you might have heard about them. And I feel like there was a lot of delivery robot startups several years ago, and I don't know, I think they kind of failed. I know some are still going on, but I think even Amazon rolled back, what they were working on. Amazon Go. Has anyone been to an Amazon Go store before? One of the stores where they have just computer vision basically looking at what you're doing, and then it charges you when you leave the store. And it kind of feels like you're stealing the first time you go because you don't have to talk to a checkout person. If you haven't gone to one yet and there's one around you, I definitely recommend it. It's pretty interesting. If email spam filtering, I'm sure we've all experienced this before. And if you're as old as I am or a little bit older, you probably remember the days when spam filtering was really bad in email. Like I remember my Yahoo account would get so much spam email, and now it's pretty good. Like you still get some that slip by, but for the most part, I don't get too much spam. That isn't something I actually like sign up for or gave my email to. Self-driving cars, chatbots, and then some other applications, again, in industries that aren't maybe your traditional big tech. You have like healthcare, smart home devices. Agriculture is a huge one. There's so much stuff popping up around agriculture that, and it might not be something people think about, but the scale that agriculture, or that people need to improve or can improve agriculture is kind of insane. So like if you can use some sort of computer vision thing or a robot to do something better and much faster, it can save a company like a lot of money or yield way better crops. There's a really cool startup here in Seattle called Carbon Robotics, and they have these robots that drive around, and they have lasers that shoot weeds. So you use computer vision to find weeds and shoot them with a laser, and it's really cool. And then manufacturing. This is actually how I got into machine learning, was building a computer vision thing that I could kind of bring over to random factories, and it could say if a part was good or bad or not. So actually, just in the example I talked about, like I trained a computer vision model with a whole bunch of examples in good and bad, and then it was able to classify good or bad parts when I could show it in front of a camera. Does anyone have any other industries they want to note or that they're really excited about? Because this isn't all of them by any means. Somebody said, yep, someone said, yes, they went to Amazon Go. Someone else said Amazon Go. Yep, super convenient, but always expect to get nabbed. Oh, like you're always expected to get nabbed because it feels like you're stealing, like I said. You walk in, if anyone hasn't gone before, you walk in, you scan a QR code, and then you kind of shop just like normal, and then you walk out. It's pretty interesting. And I do love it. I feel like I've gotten pretty spoiled. Someone said yes for Amazon Go. They're part of the testing for the palm scanning device. The one near me doesn't have the palm scanning device yet, so I haven't signed up. But if they had it, I'm sure I would have by now. And someone said they're a retired mechanical engineer experimenting with neural networks to control machinery. That sounds pretty cool. They have a couple of Jetson Nanos and some Arduinos. Awesome. Yeah, I have a couple, or at least one Nano and a whole bunch of Raspberry Pis. And I want to do some more hardware projects with machine learning as well. Cool. Any other industries people want to shout out, please do in the chat. Again, like I think one that comes up a lot too is like dental care. Drone delivery is a big one. Someone said it sounds like you could integrate quadricopter video monitoring of farmlands and analyze and harvest progression with ML. Yeah, I think there's companies already doing that with like drones flying around and taking a lot of images of crops and doing a lot of predictions with it. I just saw there was another Seattle startup too called Orchard Robotics. I haven't dived super deep into what they're doing, but it might be something similar to that as well. All right, so let's talk a little bit about some types of machine learning. Again, this is just high level here, so if you've never done machine learning before, hopefully this will be a really good little intro for you. So supervised learning is one of the most popular forms of machine learning. At least that was before generative AI. And supervised learning uses a data set that's labeled. So in this context, and this is actually, we're going to build a predictor that can do this for us today. So in this context, we have these four first columns here are all features of our data set. So that means like they're values that pertain to a piece of data. And then with those values, we want to make a prediction of what class it belongs to. So in this case, the class that this belongs to would be species. So this would be a training data set here. for flowers, and we have something called sepal length, petal length, petal width, and then a value for each of these. And so we can pass in all these features here to our machine learning algorithm, and then also tell it what target or what label it belonged to, what species it belonged to. And it'll start learning patterns from all these features. And then when we pass in just a feature without a classification, it can make a prediction for us. So I think I just explained what this slide actually said. So another example might be like spam filter. You could pass in, text from an email, say this, this is spam, and it's going to start picking up in patterns of what maybe makes up spam. So there could be misspelled words. It could be asking for, certain things over and over again. But again, so if we just pass in these features now, after we trained our model on a whole set of this, which is what we're going to do here in a little bit with code, then we'd get a prediction. And then you have regression, which is pretty similar to what we just saw here for like our classification example. Except for instead of classifying like what species something belongs to, we're trying to get a whole a number. So it could be anywhere from like 0 to a million or whatever, right? And that's used when you're trying to predict something like a stock price or an age. So it's not a class, it's a number tied to those features. So there's a famous data set that was a Boston housing data set. And here's a little snippet from it. You have something like crime rate, zoning, rooms, square footage, and then based on these types of features, you're going to try to predict the price of the house. You have unsupervised learning. So instead of having labeled data, like these other two examples, right, we have species, the target value for our classification, and then we have our price for our regression. Well, if we just had a data set and it didn't have any labels yet, we could use something called unsupervised learning, and we could kind of figure out clusters that are in here. So this could be really good if you have like a massive user base or customers shopping on your online store, and you want to find similar customers and all give them a specific ad or product or something like that, but you don't have specific labels for that. Well, you can have an unsupervised machine learning algorithm go through and start finding patterns in your data. And so in this case, you could see that like, oops, this is clearly like one clump here, and this other one could be another clump, and then this other area could also be a clump. So it's a way of kind of segmenting out patterns that don't necessarily have labels tied to them yet, but then you could go through and maybe give a label to that. Deep learning, which you can do regression and classification with, or also, deep learning is basically artificial neural networks put together. And I don't think there's a formal definition of how deep it has to be for it to be called deep learning. Some people say like 3 layers, 2 layers, 5 layers, etc. But basically you're building these things called artificial neural networks, which we won't go too deep into in this workshop. That'll be a different one if we want to do one on deep learning. But you pass in data to these really kind of complex neural networks, and they are really good at finding patterns. So anytime you see something cool right now, it's probably using deep learning, like for computer vision, natural language processing, some form of deep learning is going on. But you don't always need deep learning. So it can be really expensive. Sometimes a much simpler machine learning algorithm works great, and you don't necessarily have to have deep learning going on. But a lot of the cool stuff that you see right now probably does have deep learning going on behind the scenes. Oh, also it can be really hard to explain. So if you work at a company like an insurance company or a bank, there's a lot of laws around, if you're denying someone a credit card, etc., has to be kind of proven like why you made that decision. And neural networks can be really hard to understand exactly why it made that decision. They might be really good at finding patterns, but they're not very explainable. Even though there are some tools to help with that, you might want to use a more traditional ML algorithm or something that actually you can decipher a little bit better. So there's a whole bunch of other types of machine learning, like reinforcement learning, which is often used in games, or like some other environments. It could be real world environments too, or tied with other types of machine learning. But basically, it's a form of trial and error. You have an environment state, and then you get some sort of feedback reward. So is it doing good or bad? And that's why it's so good at games, because usually you have like a score that's associated with it. Does anyone remember this game, Flappy Birds? It was really big. I don't know how long ago. Was that 10 years ago, 15 years ago? It took like the world by storm, and then I haven't heard about it in a long time. But this is an example. Someone used a reinforcement learning algorithm to kind of learn how to play Flappy Birds incredibly well. And I'm pretty sure people were doing this at the time when it was out because some of the scores were insane and I don't think humanly possible. You have semi-supervised machine learning, which is a way of kind of combining, the unsupervised, like we talked about here, and supervised together. We can kind of you have some informed things with labels, but then you can actually start learning patterns from unlabeled data as well and kind of combine that together. And then also we didn't talk about really recommendation systems as a form of ML here, but we talked about it in the use cases like product recommendations. It's actually probably one of the most widely interacted things with machine learning right now, because anytime you open up like a social media feed or anything like that, or Amazon, there's a recommendation system there serving you some sort of result usually. Choosing a model. So really just to get started, or when you're getting started right now, just think about, what type of prediction do you need? Do you need a classification? Like, are you trying to predict, does this belong to a certain species of animal? Are you trying to predict a number, like a stock score or an age? Then that would be a regression problem. Otherwise, the classification one. Does the model need to be explainable? Again, if you're just starting out and doing this for fun, maybe it's not something you need to think of right now. Really think of like, how will you measure success of this model? And then you can work backwards from there. Also, if you're putting this in production, do you have any hardware constraints? Someone mentioned running ML on like a Jetson Nano, or if you're doing it on a Raspberry Pi, you can't usually just take any of the state-of-the-art computer vision deep learning models and then put it on there, because it's not going to run very well, if at all. So you have to find a smaller version often, or compile one of the state-of-the-art ones down to a smaller version to put on your piece of hardware. So, oftentimes you'll run into some sort of hardware constraint, but it depends on your use case. But when you're just getting started, just think of really what type of prediction do you need, and then you can experiment with all these different ones. So we didn't even talk about I think we'll talk about some of these here in a little bit, but it's gonna, after you experiment with them a little bit, you're gonna have good intuition of like what models to try, and that just comes with time. Oh, and I'll share this link in case it's not in the description real quick. And we'll get to the code here shortly, but I'm going to cover just a couple of the popular models, and this is the one we're going to mainly focus on in our code today, called k-nearest neighbors. So you can use it for regression and classification. We're going to be using it for classification today. And how it works is pretty simple to understand. So KNN finds the k number of nearest data points to make an educated guess based on the classification of the nearest data point. So in this case, let's say this black dot coming in was the new piece of data. So this is like in production now. We've got this new piece of data, and we have here just like this 2D plot of our other data. We have petal width and sepal length. Even though we have those other features, we're just looking at these two for now. And then for this case, you can see it's looking at the 4 closest neighbors. So that would be the number k in this instance would be 4. So it's looking at the 4 closest neighbors. What do you think the value would be returned? Like if it was making a prediction for one of these 3 classes, Virginica, versicolor, or setosa, what do you think the prediction would be here? I'm guessing you all can make a good guess here. It's got 4 legs. Maybe it's hard to see. I don't think I can zoom in when I'm presented, but it's looking at 1 here, and then this one, oops, this one, and this one. So someone said versicolor. That's correct, right? So it has 3 that belong to that class, and then 1 that doesn't. So it's going to say, I'm pretty sure, this is versicolor, but I am kind of close to this other class too, so there is some form of probability that it could be there. And we can see looking at these classes, like there's definitely some overlap between the red and yellow here. So we might misclassify those sometimes, but we could probably get a pretty good educated guess. And remember this, because we're going to implement it and also maybe see what happens when we put in data that seems really weird, and we'll see what happens. Linear regression you can kind of think of this as drawing a straight line with a relationship to kind of the prediction variable. So here, this would be like, for example, if we had the Boston housing data set again, and this is like the actual price versus the predicted price. We'd want to fit this line as closely as possible to make the correct prediction. And then there's a whole bunch of other types of models like decision trees, random forests, logistic regression, neural networks, transformers. Again, we can't go into all of them today, but they're all different ways of doing very similar things. So if you're doing a classification problem or a regression problem, you're going to see these models come around and you say, well, which one do I need? And you could pick like k-nearest neighbors, a decision tree, a random forest, logistic regression for binary classification. Neural networks could do classification, but then you're going to kind of go, okay, well, do I have enough data to train a neural network? Do I need something that robust? Do I need something pretty explainable like a k-nearest neighbor or decision tree? Or is my data really complex? The more complex data you have, the decision tree and the k-nearest neighbors might not work as well. Like if you have a ton more features than what we're going to be looking at today, and a random forest might do a better job. And again, a lot of this is going to come as kind of intuition as you do more machine learning and like read more about it. You'll get kind of a better feel for what type of model you'll want to choose. And also you can choose more than one. It's pretty common as you're designing your ML model. Like you might take one of the simplest models here and then keep adding a more complex model and see how it performs versus the simplest model. Enough slides. Let's go ahead and do some machine learning. So I'm going to share this repo again in the chat, but it's also in the description. So if you're watching this recording later, you can come back to it as well. So also, while people are opening that up, what type of workshop would you want to see next? Would it be intro to deep learning, intro to computer vision, intro to Python? Also, actually, when I was thinking about doing, because I've been messing around a lot with just like the OpenAI APIs, would you want to see something around like, I don't know, building a simple chatbot or something like that with like OpenAI GPT 3.5 with their API? So it said all three. Perfect. Also, so you can open up this this repo. I'll share a link directly to, I guess, this Colab notebook. So if you're on this repo and you want to follow along to the code here, hit this open in Colab button or this link here, and it's going to take you to this this page, something that looks like this. I'll share the direct link in the chat as well. But if you have the repo, you should be able to open this. Once you're here, go to File, go to Save a Copy and Drive. This is going to give you your very own copy of this notebook, and then you'll be able to adjust the code, save versions. You can always come back to it if you want, and don't worry about breaking it. You can always come back to this original link. So if you want to bookmark that or just start the GitHub repo or something like that, you can always come back to it anytime, so don't worry about breaking it. So I'm going to go ahead and do that here to Save a Copy and Drive. And let me maybe zoom in a little bit more for the screen. Hopefully that's good for everyone. And then if just at least one person wants to let me know you saved a copy and drive, that'd be great. I'll give everyone a minute here. Cool, someone said done. And you can always get back to Notebook, save a copy and drive. There's some other useful links if you want to check out the GitHub, LinkedIn, Slack channel, things I shared before, you can. Oh, a quick note on Colab. So you don't have to follow along on this part, but I'll just quickly mention it's really cool. They give you a good amount of GPU time. So if we do a workshop, for example, on deep learning or something like that, or if you just want to get started with deep learning and you don't have your own GPU at home, you can actually come to Colab, hit change runtime type, and select a GPU from here which is pretty cool. Again, you don't have to do this for this workshop. We're not using anything intensive like deep learning. We can run all of our models today just on the CPU, but this is a really cool tool for you to come back to and kind of get free GPU time, which is incredible because GPUs are really expensive. All right, so let's run our first code cell. If you've never used Google Colab before, you can hit this little play button, or when the code cell is highlighted, you can hit Shift Enter, and it'll run the code cell and then kind of move to the next cell. So you'll probably see me hitting Shift Enter quite a bit. The first time we run a code cell, it's going to take like a minute here. It's connecting to an instance, and then it's going to run the output. Once this is connected, you'll see like a green check mark like this, and then we can rerun this code cell and it'll be really fast. And if you're new to Python, this is how you print out output, like text. We're saying print and then just passing in a string. That's the text in between the quotation marks, and it's outputting a value there. So let's go ahead and import some libraries here that we're going to use. Also, a quick note about Google Colab is it comes pre-installed with a lot of the common machine learning libraries. So you don't have to install scikit-learn. It's actually already installed, and we're just going to import it in. Someone said, what do they do once they save the Google Drive? So once it's saved, like I'm in my copy here, just start following along and running these code cells. So run this first one, and then now this is your copy, and you can edit this and save versions of it. And let's go ahead and import from the scikit-learn dataset package, load iris. So if you haven't used Python before, we're saying from this library that's already pre-installed, that scikit-learn's already pre-installed here, and then we're going to import something called load iris, which contains a dataset that we're going to be using today. So we're going to print out iris. This is what was loaded. Don't be scared. It looks crazy right now, but we're just going to format this better for us to look at. But we can look at and see this is an array. And here's a whole bunch of values. These are those features that we kind of saw a preview of in the slide before. So the petal length, etc. And then we see these numbers here. These are the classes that these features belong to. Again, don't worry, it looks crazy right now. You don't really need to look at this. I'm just explaining what's in here, and then we're going to clean this up and train a model with it. And then we have the array, or the species names and some other kind of metadata about the data set here. So if we print the shape of it, this is telling us that we have 150 rows and 4 columns. So that's the sepal length and width, etc. That's our data rows. And then if we print the shape of our target values, we have 150 rows. Again, that's the class value. And it's good to kind of look at your data a little bit when you first import it in to make sure that it's matching up or looking the way you should. So we'll look at our data a little bit more here in a second, but even just knowing that, okay, there's 150 rows of data, and then there's 150 classes, that shows that it's the correct amount for each one, and we're pretty confident, especially in this case, that it's going to match up to our data set. Now, if you wanted to bring in your own data, it's actually pretty easy as well with scikit-learn or with pandas. It makes it really easy to read in like a Excel sheet or a CSV sheet. So you could have this data stored as a CSV, and then you can just call something read CSV from pandas, which is imported as PD here, and then you'd be able to read in your own data. So today we're downloading like a clean data set from the scikit-learn library that's going to make it really easy for us to get started. But if you have your own data stored somewhere, like or from work or something like that, and you actually want to play around, train your own model on your own data, which I totally think you should, you could pretty easily read it in using this function built into pandas. So it's a pretty common step to kind of first explore your data a little bit more before you train a machine learning model. So let's say, we've never seen this data before, which is a very famous data set. So if you've ever looked at machine learning before, you might have, and I know I've seen it before, but let's pretend like we haven't. So first we're going to import pandas as PD. What we're saying is import the pandas library and as PD, so we can call it with just .pd instead of writing pandas. And this is like the convention, like every time this is imported in anything, it's always PD now. So if you see this anywhere, it means pandas. And then we're going to overwrite the settings a little bit. So when we call it, we'll just see all the columns. We'll see what this looks like in a second. But pandas is a really cool library in Python that allows us to use something called a data frame. And I kind of like to think of this as it's like Excel, but in Python, and you can do a lot of cool stuff with it. And we'll see it in action here in a second. And then we're going to use something called matplotlib for visualizations, and we're going to use a library called Seaborn for other visualizations. So now let's create a data frame. We're going to call it df. So this is a variable in Python, and then we're assigning it this data frame that we're creating with pandas. We're passing in that iris data, and then we're just saying the column names are going to be equal to the feature names that were in that iris data that we saw earlier before. So we'll run that, and then we're going to run something called df.head, so dataframe.head, and that's going to return the first 5 rows here. And if you want, you can pass in different numbers here, get the first 10, or you can just say df in this case, and I'll return all the rows. So we have, I thought we overrode that. Well, we get all the rows except for, we get the first 5 and the last 5. And I thought this should have overwritten it. They might have changed it since they probably did an update, and it's probably something else now, where you can display the whole table here. I'll go back to .head, and we could actually probably just pass in 150. Oh no, we'd still have to overwrite it. But we see this contains our features like we saw before: the sepal length, sepal width, petal length, petal width. And I didn't know what a sepal was either before, and it's kind of like an underbelly petal of a flower. And these are all measurements someone took, measured in centimeters, and then they logged them. So let's go ahead now and investigate our data more, but we're going to create a data frame that contains our classes, so we can actually visualize this a little bit better. We're going to import NumPy, and then all we're going to do with NumPy, which is a really cool library for doing matrix multiplication, a lot of really complex, cool stuff. But all we're going to do is something that's like a column concatenation. So we're basically just taking this data frame, and then we're going to load in the classes from the other piece of our data and just really append it to the end here. And you'll see what I mean when you run this code cell. If you look at our data frame now, you can see that we have this target column. And then in that target column, we have 0, 1, and 2. And each one of those numbers aligns to one of the 3 classes, the Setosa, Versicolor, and Virginica. And then we could call dataframe.plot, pass in time, type of or kind of scatter, and then say which x-axis and y-axis we want. So in this case, we're saying sepal length and petal width. This just has to matches the column exactly. So you could come up and copy this in if you wanted to change this around. The C here stands for color map, this stands for color map, and then this is saying we're going to change the color based on target. So we have those 3 targets. Targets and labels can kind of be terms can be used interchangeably. So you have Versicolor, etc. Except for right now, they're just encoded as numbers. So we have the 0, 1, and 2, and we can see that now we have this color map of these are yellow, these are red, these are purple. And we get a little bit of an idea so far that, let's say, we don't have an ML algorithm yet, but we're kind of understanding that could something find patterns in this data? Just looking at this 2 dimensions right now, do we think like a machine learning model could? And we saw an example of the k-nearest neighbors looking at a view that was similar to this anyway, right? And it came in here and predicted that it would belong to this class by looking at the closest 4 neighbors. And we can see that for the most part, they are kind of clustered pretty good, especially this pink class. They're all the way down here. You could even write probably a pretty simple if statement, right? And say if the petal width is below 0.8 or whatever, it would always belong to this class. And that might be right. Here we can see there's some overlap like we saw before, but they're probably like clumped enough that we could get pretty good prediction results here. Let's look at all the variations, and we can do this really easily with something called a pair plot from Seaborn. So we're going to import Seaborn. We're going to give it our data frame. we're going to say change the hue on target, just kind of like we did before on the other graph, the other plotter. And this is a pair plot. So this gives us kind of every variation that we could be looking at our data in 2 dimensions. Here we have the sepal length, and then this is actually saying kind of like we have these little bell curves. This gives us kind of the values of the sepal length per class. And the more separate these are per color or per class here, kind of the better odds we would have of separating them from each other. So we can see there's, quite a bit of overlap here, but definitely some separation. If we look at this bell curve, like let's say we just had sepal width to determine what class our flowers belong to, there's a lot of overlap here. And it would be really hard to get some of these, to separate some of these classes out if this is the only value we had to look at. And you can look at the overlap here. To me, at least visually, it seems almost impossible to pick like this really dark color to this kind of pinker color. That would be really hard to separate what class belongs to what. And here we can see that the petal length, there's some overlap, but not an insane amount. And then definitely the petal width, there's some overlap here, but not an insane amount either. So this gives us a good indicator too that these features are probably going to be really strong for our machine learning algorithm. And these ones might not help that much potentially. And in fact, I don't think it's in here, but I've done this before where you can use like libraries to give you feature importance, saying which ones are the most important to your machine learning model. And if you're using something like k-nearest neighbors, like we are going to here in a second, these are the 2 most important features, and you could get rid of basically these 2, and it was still performing just as good. But this is also really good in a really important part of the phase, like this exploratory analysis phase. We have a really clean data set here because it's a toy data set meant to kind of make it really easy to train a machine learning model. But this would be a point too where you're looking at outliers. We don't really have any that are clear outliers here, but if we had data that was like, way outside and not even near anything else, chances are that's some sort of outlier and we might want to clean it up or figure out what's going on there. Maybe before we pass it into our machine learning model. And that's going to be a pretty common thing if you're actually doing this in production, is like the data is going to be all over the place potentially, depending on how you're getting the data at your job. And sometimes I kind of forget what the exact column names. You can just kind of quickly get it by calling df.head. We print out just the first value here. I wanted to do that just to show that if you're building like a more custom graphic, you could take those column names. Oh, I didn't edit it here. So in this case, like you could do more custom pair plots by just doing like 2, for example. Because we only have 4 features, this is a really simple data set. Most of the time, you might have like way more features, like 20 or 100 or something like that. And if you tried to do a pair plot on that, it would look awful and you wouldn't even be able to read it, and it would take a long time. So you might want to pare this down to like, 10 features or less, and then kind of get the comparisons that way. So you can easily do that by specifically passing in which columns you want to look at. And then this is a quick example like of using matplotlib if you want to build a more custom chart. So like before we had all those numbers up here, I just wanted to show that you can kind of really easily customize like and make a pretty graphic with matplotlib. This just has text kind of describing stuff in here. So if you want to come back to this, you're more than welcome to. And then we're just building a little formatter here that instead of displaying the numbers, displays the text here. And then there's a whole bunch of stuff that you can choose in matplotlib, like what do you want the access name to be, what color do you want it to be, etc. And these are all just variables you can set and mess around with. All right, so we've kind of looked at how to look at your data, how to make a chart with your data. And I know, this is pretty brief. It's a quick intro. So there's a lot more you can learn around like data cleaning and monitoring for outliers, etc. But let's move on to training our machine learning model. So this is the machine learning part here. We're actually going to train a model. So again, if it's your first time, hopefully this will be really cool and show you that it's not that hard to train a machine learning model if you know a little bit of Python code. And then just building up intuition around those models. Like I mentioned, you don't necessarily need to know all the math that goes on behind the scenes with them, but you should know kind of how they work and when to use them, and also when something's going wrong, why something's going wrong with them. So even if you don't know exactly all the math, but you kind of know like what's going on behind the scenes, that's going to help you a lot. So here we're going to import from scikit-learn something called neighbors that contains our k-nearest neighbors algorithm. And we're going to also import something called train test split, which we're going to use to split our data set up into two, which I'll talk about here in a second. So we're going to also assign just the data. So that's just the variables, like the measurements from our sepal and petal lengths and widths. That's going to be now this variable x, and then you're going to have a variable y. That's going to be our target values. This is typical notation in machine learning, where your features that you're going to train your model on is x, and then the ground truth labels is y. So it's a common annotation that you're going to see. Then we're going to create these 4 variables here using that train test split function that we imported in. So we're going to get x train, s test, x test, y train, y test. So x train, that's just the features, right? That were the petal length, etc. in there. And then y train is going to be the correlating labels that those features belong to. So like setosa, etc. And we'll see what this looks like in an array a little bit later. So if this does seem really confusing, I think it'll make more sense when we see it after we do the prediction. And then we have this x test and y test. And what we're going to do is we're not going to use these to train our model on. We're going to train our model on these train ones, and then we're going to have this test data set that our model never saw, and we're going to see how it performs on it. So it's really common in machine learning, deep learning, that you have multiple data sets or like tests, like subsections of your data set. So training, your model's trained on that, and then you have a section of your data that's never seen before. You're going to run your model on it, see how well it did. Because if you just train on the whole thing and then ran it on part of the data that it already saw, it's kind of like cheating. It knows exactly those patterns belong to those classes. So it's a good way of measuring that your model is actually kind of learning patterns and can generalize onto data that's never seen before but are similar. So inside our train test split, we're going to pass in the x and y values, which is our data and target. We're going to say the test size is 20% here, so we're going to put aside 20% of our data to look at later. We have this random state, so it's going to shuffle our data up, but it does have the seed value, so you could pass it in and kind of get that same shuffled state if you wanted to look at this later. And then there's a value called stratify that you can use for classification problems, and that's going to kind of try to equalize the amount of class for each for the test and train. So if you just split it like down the middle, we might not have any of the class 3 or like versicolor or whatever the last one was. Maybe none of that would have made it into our training data, and then it was all on our test data set, and our model probably would have done pretty poorly with that. So we're making sure that a certain amount of each one is going to go into the training and test data set as equally as possible here. But you can't do that with the regression one. And then here, we're going to call a variable k&n. We're going to assign it to that k nearest neighbor classifier. By default, I guess in here I have it set to 1. You can run this as 1 if you want. I'm going to set this to 3. So it's going to be looking at the closest 3 neighbors right now. And then you can adjust this number and maybe see how it performs. Like, does it perform better or worse if you make it go up or lower? And then we're going to call knn.fit. This is actually the training part. And how it kind of really works with knn is it's loading in your whole training data set. And then when you get a new piece of data, it's going to be looking at, just like we saw, you get a new piece of data, it's going to be looking at proximity to the other classes in this data set. So if you have a ton of data, knn I think can perform kind of slowly on it because it's like holding too much data inside of it. And then here we're going to get our predictions. So we're going to pass in that x test here and get what the prediction values were. So let's go ahead and run this. And if you just ran this, and if you've never done machine learning before, you just trained your first machine learning model. So congratulations. Hopefully, hopefully it's exciting and fun, but maybe not too much of a letdown because it didn't look super cool when we did that yet. So here I'm going to print out the predictions from our model and then the ground truths. So the top one is going to be what our model predicted, and then these are the actual ground truths from our data set. And eyeballing it, it's hard to tell if was this 100% right? We'll find out, because eyeballing an array can be hard. I think there's one that's messed up. Oh yeah, so this one is messed up. So our model did a pretty good job, but we can see this was mispredicted as a class 2, when really the ground truth, it was a class 1. And we'll see how to kind of better look at this here in a second. And we can call this .score method, pass in the x test, y test values. So again, that's just our testing data set and see how well it did. And it was 96.66666%, basically 97% accurate on our data set, which is pretty cool. If we want to have a better way of visualizing this, we can use something called a confusion matrix. So this kind of plots out. I'll run the next one because it's even cooler looking. Inside Seaborn, you can use this heat map function, pass in our confusion matrix, and this plots out the predicted classes versus the actual class. So this is the ground truth going down this way, and then this is the predicted this way. So you can kind of have this heat map, which can be really helpful if you have a lot more data than what we have right now to kind of see how your model is performing. So here, this is 100% correct. We can see that on that class 1, it was almost correct, but it got 1 wrong, and it mispredicted it as the class 2. And class 2 was 100% right. So this gives you a good insight of, like, it's not that it was just wrong, you actually see which one it mispredicted. And then we can go look at our data, which if I scroll back up to our data set, we saw that there was a lot of overlap between these two, the class 1 and 2s. And, it probably looked at the closest 3 neighbors, and the closest 3 were the other class, even though it belonged to the other one. So we can understand why it could make that mistake. And then we looked at the score. Here is accuracy score, but there's other scores you might want to use depending on what your model is doing. So you have things like precision, recall, F1 score. F1 score is kind of a way of mixing all these things together. It's pretty commonly used. So one reason why you might want a different measurement over just accuracy, like imagine if you're building something that would detect guns and x-rays at an airport, and 99% of people don't have guns, or 99.9% of people don't have guns going through. So even if your model just always predicted they don't have a gun, it would be 99.99% accurate, right? Even if it was wrong on that 0.1% of the time. So for something like that, you might want to have a higher recall score. So that's saying that, like, it might be wrong more, but you'd rather have kind of it be overcautious and predict that, like, a gun might be there versus it not catching when it is. So if you've gone through an airport before and they're scanning your bag and they have you open it up, it's because they have, like, this higher recall thing. They'd rather predict that, hey, there might be something there, you want to go check it out. Go check it out and verify, versus no, like, we don't care if we're as precise here. We'd rather have, like, a false prediction and then verify it with, like, a human in the loop in that case. So you'd want to use something like recall to measure something like that. All right, so let's try our model on some new data. I'm going to create a variable here from an array. So this has all the class names. Setosa is 0, Versicola is 1, and then Virginica is 3. And we have a little function here. We're going to pass in features. So we're going to pass in the 4 features like we've seen before. We're going to make a prediction on that and then print out the result, the predicted class, and then a probability score that goes that came from our model. So let's run this one, and we can see that I guess they updated something in the library, and I'll have to update this later. Last time I ran it, we didn't get this error, but we still got all the data here. So predicted that it was versicolor with a probability of, like, 66%. So we're looking at, in my model, it was looking at the closest 3. So 2 of them were probably versicolor, and 1 of them was not. And so it's saying, I'm pretty sure it's that one, but I did see another one of a different class. So potentially it's not. What do you think would happen if we put some crazy numbers in here? And anyone, I know if you're following along, putting your own numbers, what numbers should I put in here and see what happens? We already have some that might be out of range, like 6, 20, -1. Any other crazy numbers that we should try and see what happens with our model? I'll put in 200, and I guess let's put in like -1,000, and we'll just put another one like 89 or something like that. What do you think's going to happen here? Well, it still made the prediction, and it's predicting that it's Setosa. And it's 100% sure. The reason why, because we don't have any guardrails or anything on our data or our model right now. So if trying to go back to just one of these real quick, I guess I'll just, pull up this one. So if our new piece of data is way outside the realm, so we did a really high number in this case, I think, for a lot of these. So let's say it's like way off the chart over here, like way out of scale from anything else. It's still just looking at the closest 3 neighbors in this case, so it's going all the way back here and saying, yeah, like it looks like it's Setosa. Those are the 3 closest ones. So we should probably have some sort of data quality check or something if this is out in production to make sure that, the maybe we expect our data is going to fall within a certain realm. Like we might have a buffer, like maybe our flower petals do get a little bit longer, etc. But this seems really extreme, and this would be probably a data quality problem that got into our system. Or flowers are like mutants now and are very different. But it would be weird to have a negative number. So you might even have a data quality check thing be like, nothing should ever be negative because we're measuring something in centimeters. It could maybe be 0, but it shouldn't be able to be a negative number. But that's not built in by default to our ML model. That would have to be something we kind of define around it. So there's a whole like field around data quality and also monitoring data in production, which I used to work a lot in as well. So if flowers did change over time, like they were getting longer and longer because, I don't know, there's more sun or more water or something like that, and potentially years later, if we, or not even years usually in real problems, but potentially like maybe the next crop or something like that, the measurements are off because everything was a lot longer for some reason. That would be like a sign of data drift where our data coming into our model, like for predictions, really no longer matches what it was trained on, and we'd want to take this new production data or new data that we have on flowers and like retrain our model because it's probably not going to fit anymore. A good example of that is also like if you trained a housing price predictor like we talked about earlier, if you trained that 5 years ago, do you think it would do well today or 10 years ago? No, because the prices are drastically different than they were like 5 or 10 years ago. So you have to think about how often you kind of want to recapture data from production often if you already have a model in there, and then retrain a model. There's a whole bunch of cool stuff you can look up about doing that as well. And we already talked about that. There's Pandera, which is a open source project that we actually maintain at Union as well. You can check out, that's on this kind of data quality checking problem. And then I do have a bonus part in here. You can kind of go through this on your own if you want. I'll skim through it really quickly since we're just over time here a little bit too. But it's doing pretty much exactly what we're doing, except for with a linear regression. So if you kind of could wrap your head around what we were doing here with like importing stuff from scikit-learn for the k nearest neighbors model, you could do this with linear regression as well. You just import a different model. And I will say scikit-learn removed one of the data sets that was good for testing this and like showing it off. So there isn't a really good data set here, but you can kind of generate your own and fit a regression model to it. But I'm going to go ahead and kind of skip over that for now, but I'll leave it in there if you want to go view it. Other than that, though, I'll stick around for a little bit more if people have questions. And otherwise, that was our quick intro to machine learning. Hopefully, again, if you haven't done machine learning before, it made it seem easier or not too hard to get into. Like if you don't have a big math background, or maybe you thought it'd be really complex to train a machine learning model, but we just saw like not that many lines of code. We were able to use a really popular machine learning library that's used in production. And, of course we had like a curated data set for us and stuff. So it made it maybe feel even easier. But it's not crazy. It's something you could totally learn depending on your background. But definitely keep learning. There's so much more to learn about in data science and machine learning. I have some resources to stay connected here as well. And I guess I'll shout out the Slack group one more time too. So if you do have questions later, you can ping me in there. Or there's like a ML and MLOps question channel. You can ask stuff there later as well. And then the AI Book Club channel if you want to read Grokking Deep Learning with us next month. Which by next month, I mean starts next week. Someone said, thanks. This is eye-opening. Someone said, thanks for the session. It was cool to play around with toy data sets. Awesome. Well, I hope like you said, it was eye-opening. I hope that means you learned something and that you feel like you could do machine learning if you want to, especially if you've never really poked around with it before. Someone said, in real life development, do you write unit tests for the functions like KNN, or would you test anything else? Yeah, so you could write tests for it. And talking about kind of the data like being out of range, you can write kind of like a unit test for your data using something like Pandera, like I linked to, or there's another library called YLogs that I used to work at. And then also there's like a whole different one, like whole another kind of field is let me pull up something real quick, is ML monitoring. So once you have something in production, you're often wanting to kind of monitor it in some capacity, like even if that's you spot checking it once in a while, which it shouldn't technically be. You should probably have some sort of system in there, but making sure like your model is behaving correctly or that the data doesn't look super weird going in and out of it. You can use tools like I used to work at YLabs, so it's the one I often point people to. I like it. I'm building out an integration with the stuff we're doing at Union with it, but there's other tools in there in the space as well. So with that, you can be monitoring all different metrics of like data coming in, predictions coming out of your model, and looking for drastic changes. So you don't even need the ground truth necessarily in that case. You could just see like, well, the data has been looking fine over time, and then all of a sudden it drastically changed. Potentially there's something going on there. So I would be always kind of, I don't know if I'd call it a test, but I'd have a monitor on data coming in and out of your models whenever you can, at the bare minimum, in and out. You can have different parts in your pipeline too, like you could do it on transforms, etc. Really, any part you're doing in the pipeline, you could have something like that. Actually, in like Union AI or Flight, like our open source, that has like observability for probably those types of things in your pipeline if your pipeline was built with that. But then at the end part, at the bare minimum, it's like you'll catch stuff if you're doing data into your model and data out from your model. You'll probably learn a lot and catch a lot. Like if there's an error anywhere in your pipeline and the data doesn't look like it's supposed to going into the model at the end, then you could probably troubleshoot and kind of hopefully tie back to what happened. Someone said they were procrastinating, getting their hands dirty, and this really helped them to get out of their comfort zone. Awesome. Yeah, take this. So like, I mean, if you want to keep going, there's so many great resources out there and so many books and courses and, free YouTube videos and Medium articles, etc. There's a whole bunch of them. But hopefully this showed you like, oh, you could just take some code and run it. And if you wanted to, you could literally take the code we ran today, try to import your own data set. Like I mentioned, it's not that hard. You can use a built-in function, but it can be hard to get data and clean it up, etc. And you might learn kind of a fair amount just, getting a CSV in here. And then also you might have some other parameters like what k nearest the neighbors do you want to use? And also maybe the k nearest neighbor model actually won't work good on your data because it's more complex than this kind of toy data set. And so you could actually look at how to implement a decision tree, which again is going to look a lot like what we did, but you're going to be importing different libraries and stuff. And there's going to be a couple different parameters you can change to make it work better on your data. But seeing what we did here today, hopefully it won't feel too hard to get started anymore. So said, great lesson. really great start. Are you adding this to your YouTube channel? Yeah, so this is actually, if you're watching this on YouTube right now, it's going to be at the same link. So you can come back to this link anytime, and all the resources will be in that description. So it live streams in, and then actually just lives at the same link here. And hopefully I'll do a little bit more with YouTube later this year. I think it'd be cool to do more workshops, and also maybe just a little bit more like recorded videos on doing some of this stuff. With that, I think I'm going to go ahead and wrap up the stream here. If you have any other questions later, feel free to contact me in the Slack channel or on my LinkedIn. Those are probably the two places I'm pretty active at. And hopefully I'll talk to some of you all later.